What a quadratic graph is, this is where we've got an x squared in it, which therefore gives us a positive parabola, a smiley face, or equally it might have a minus x squared, in which case we get a negative parabola or a sad face. Now, just while I notice it there, do remember when you're sketching these, you'd always make sure it doesn't have a flat bottom. It's not a vase, it's just a nice gentle curve. Now, in the past, we've done the plotting of them. So this is a lesson from years gone by. And if you remember, we really hone in on the symmetry. So we work out all the values, but we're always looking out for the symmetry. So that's not today's lesson. Today's lesson is a more sophisticated one, where we're not going to try and plot the graph. So we're not doing it accurately on graph paper. We're going to be just sketching it and getting all the key points. Now, the key points are two things. It's where the curve cuts the axes. So that might just be the y-axis, like here. But obviously, if the smiley face was further down, it could be cutting the x-axis as well. And more specifically, we're going to be trying to work out what the minimum points are. So the minimum point, and I think all the ones we're doing today are positive parabolas, so it's going to be minimum points. Of course, if we were working out the turning point on a negative parabola, the turning point would be a maximum point. So when we're sketching a quadratic graph, we sort of just work through a number of routines to work out various bits and pieces. So we're going to want to work out the roots. So that's when we say the roots, that's the answers. That's where it crosses the x-axis. So that's when we set it equal to 0, does it cross the x-axis? As I said, sometimes it will. Sometimes if the curve was above the x-axis, it won't. So we're going to work out the roots, if any. So that's where the graph crosses the x-axis. We're going to want to work out the turning point, as I said, so the maximum or the minimum. And then thirdly, we're going to want to work out where the graph cuts the y-axis. Now, to work out the roots, this is where the y equals 0, so we just set it equal to 0. So if we've got, for example, this example here, x squared plus 8x plus 12, we just set it to 0 and we factorise it. Or if we can't factorise it, we might use the formula. So let's just remember how to factorise. So what two magic numbers multiply to be 12 but add to be 8? So that's 2 and 6. So factorise, we've got x plus 2, x plus 6 equaling 0. So our roots, our solutions are minus 2 and minus 6. So when we do a quick sketch, we can see our roots are at minus 2 and minus 6. Now, for the minimum point, because the graph is symmetrical, we don't actually need to do anything other than rely on the symmetry. So one strategy is just to say, okay, it cuts the graph at minus 2 and minus 6. Sorry, it cuts the x-axis at minus 2 and minus 6. So the minimum point must be halfway between these two, which is minus 4. And then we could just substitute minus 4 back into the curve itself to work out what the y-coordinate was, and we would indeed get minus 4, minus 4. But what I want us to do is to remember that completing the square is a very quick way to also find out the minimum points. So I want, as we're doing all of these, I want us to consistently not just rely on this symmetry, I want us to separately complete the square to double check that indeed the minimum point is minus 4, minus 4. So how do we complete the square? Remember what we do, we start off by halving the coefficient of the x, so the plus 8 becomes plus 4, so we have x plus 4 all squared. Then we picture that pair of brackets, x plus 4 times x plus 4. You do the for clause, and you're going to get x squared plus 4x plus 4x plus 16, or in other words, x squared plus 8x plus 16. But we don't want the plus 16 bit, so we've got to back out that plus 16 with the minus 16. So all of that bit there, all of that underlined there, is what equals x squared plus 8x. Then of course we've got the plus 12 as well. So that's the key bit. Now obviously the next line we've just gathered up a minus 16 and plus 12 to have the minus 4. And that's it. We've gone and rearranged it into completing the square format. Now, as we've mentioned before, one of the benefits of completing the square, of getting into this format, is that you can just by sight see what the minimum point was. Now the minimum point is where the y coordinate is as small as possible. Now when we square anything, the smallest we can get is 0 when it's 0 squared. So at the minimum point, we want to make this bracket 0. So how do we make this bracket 0? X is minus 4. So there is our x coordinate of our minimum point. Now when x is minus 4, what y coordinate does that give us? Well, obviously this bracket becomes 0, that's the whole point, and then we're left with minus 4. So we've actually shown by completing the square that our minimum point is indeed minus 4 minus 4. And then finally, what have I done? I've gone and worked out where the curve cuts the y-axis, and this is dead easy. You just substitute 0, because our x value is 0. We've got nothing along the stairs. You substitute 0 back into the curve. And obviously 0 plus 12 is 12. So for all of the questions going on, we're going to work out what the roots are by either factorising or using the formula. We're going to work out what the minimum point is by symmetry, and we're going to double check that minimum point by completing the square, and we're going to sketch the curve, making sure that we also include the coordinate where it cuts the y-axis. So the first question, I want you to go and sketch this quadratic graph, please. So the sketch is over here, obviously hidden, and over here is where I've gone and worked out the roots, and over here is where I've double checked the minimum point. So pause the video and just have a go at doing this sketch, and obviously just start the video again when you want to see the answers. So obviously this factorizes. What magic numbers multiply to be 32 to add to be minus 12? That's minus 4 and minus 8. So that's our factorized pair of brackets, so our solutions are 4 and 8. So when we go and sketch the curve, we can see the minimum point is, sorry, not the minimum point, it cuts the x-axis at 4 and 8. Now from symmetry, the minimum point must therefore be halfway between 4 and 8, which is 6. And when I substitute 6 back into the curve, I would indeed get a y value of minus 4. But as I've said, I want us to appreciate one of the strengths of completing the square is that it easily allows us to see the minimum point. So I want you to have done a separate working to prove that the minimum point is 6 minus 4. So remember, the starting point when we're completing the square, you halve the coefficient of x, so halve the minus 12, which is minus 6. When you do that pair of brackets, x minus 6 times x minus 6, that fourth claw is going to give you plus 36, because minus 6 times minus 6 is plus 36. So we need a minus 36 to back that out. Minus 36 add 32 is minus 4. And then at that point, we can just by sight see that the minimum point must be 6 minus 4. Now 6, because that's what makes the bracket equal to 0. And minus 4, because when you substitute 6 in and make that bracket 0, the y value is just the minus 4 on the end. So we've shown that the minimum point is 6 minus 4. So question 2, so same thing, please pause the video and go and sketch this graph, working out all the roots and the minimum point, please. So pause the video. Okay, so here is my answer. Oh, thinking about it, I think on question 1 I forgot to go and say where it cut the y-axis, didn't I? Yes, so going back to question 1, when x is 0 and we substitute 0 into this, we do indeed get the y value being 32. Sorry, I forgot to mention that. So back to the question we're on. So let's go and work out the roots, so where it crosses the x-axis. So let's go and factorize, whoops, I've done it the other way around, this one. So let's go and work out the roots. So set it equal to 0, because it cuts the x-axis when y equals 0. So what magic numbers multiply to be minus 8 but add to be plus 2? That's 4 and minus 2. So they are the numbers in our factorised brackets. So our solutions are roots are minus 4 and plus 2. Now, as I said before, we could go and work out the minimum point by symmetry. There's a gap of 6 between minus 4 and 2. So if we go 3 along, we do indeed get to -1 being the x-coordinate of the minimum point. Substitute -1 back into the graph, the equation of the graph. We will go and get -9 as the y value. But just proving that by completing the square, when you complete the square, you get this, which supports the fact that our minimum point is -1 minus 9. Question 3, so same routine, pause the video, solve to work out the roots, complete the square to work out the minimum point, and sketch please. So, what you find here is that you can't solve it, okay, because the curve does not cross the x-axis. So when you try and factorize this, it won't factorize. When you try and pop it into the formula, you will find that the bit underneath the square root gives you a negative, which can't actually happen. It doesn't exist. Okay, that square root bit's actually called the discriminant, and that's something we'll do at A level. But because the discriminant is less than 0, there are no real roots. Okay, so what can we find out? Well, we can still find out the minimum point, and we can still find out where it crosses the y-axis. So it crosses the y-axis when x is 0. So 0 add 0 add 16 is clearly 16. So it crosses the y-axis at 16. Now to find the minimum point, we can't now rely on the symmetry. So that's why it's really important we do know how to complete the square. So completing the square on this, we get y equaling x plus 2 all squared plus 12. So our minimum point is -2 plus 12. All I've done over here in pink is just explain to people why we get this -4 on the end. So you can ignore the pink bit. Okay, then to finish, I've got this, which you can see in normal circumstances would be a prep. So work through these. What I want you to do in particular is to sketch it, work out the minimum point, and work out where it crosses the y-axis. I am not overly worried about you working out the roots for these, so where they cross the x-axis. That's because these don't tend to factorize, so you're going to be having to use the formula, and some of them don't even cross the x-axis. So just to repeat that again before you have a go, I want you to sketch it, okay, and to include the minimum point and also where it crosses the y-axis. So please have a go on these. Okay, and pause the video now and then I'll reveal the answers in a moment. So, with the first one, the minimum point was at -5 minus 18, crossing the y-axis at 7. The second one, minimum point at 5 minus 32, crossing the y-axis at -7. Third one, minimum point 24, crossing the y-axis at 8, and then finally minimum point at -3 minus 2, crossing the y-axis at 7. So I hope you took on board what I said. So I didn't want you to find the roots. Okay, I didn't want you to find the roots. Excuse me. Now, where are we then? So I think most of you have now got into the position where you know how to upload onto your class notebook page on Teams. I'm really keen you get familiar with that. So what I'd like you all to do, please, is to upload just one sheet of A4 of whatever you've done from this video. So please load that up. Let's try and get organized. So let's go and put it, it's not really prep, so can you go and put it into classwork? And then it would be great if you could just set up a new tab and just call it 12.1 sketching quadratic graphs. So I really want your class notebook page to start looking like your folder at school, so we have a separate tab for each lesson. So if you could do that, and then what I want you to do, please, when you've uploaded it, can you, again, on the notes and on the posts page, it's called, isn't it? Posts page of Teams, can you just let me know that you've uploaded it? Then I will go and have a look and give you a little smiley face or something. Okay, bye then.